Mayo has a unique history, actually, in the origins of aeromedical space physiology. In Rochester at Mayo Clinic, Dr. Wood and Dr. Ed Lambert created what's called the G suit, which is used by many pilots and fighter pilots to prevent low blood flow to the brain so that they don't pass out. So Mayo really has a unique history in aeromedical and space, and we are excited because we are pushing the boundaries of science, trying to learn about microgravity and space, especially for passengers or patients, if you will, with the burgeoning field such as SpaceX, Virgin Galactic, Blue Origin, and humans that are going to be traveling in microgravity.
The current state of monitoring of astronauts is they're working on making smaller and smaller wearable technology. And that still has a problem of that the astronaut has to wear, stickers of EKG leads or something like that, and a battery pack. And this new technology is going to actually reduce the footprint, because it's a very small camera, reduce the amount of space required on a rocket or on a space station. And on top of that, it doesn't require to be worn, it doesn't require battery changes or anything like that, because it can measure vital signs from a distance. And not only is this going to be helpful for astronauts, but we believe it's also going to be helpful potentially for the space tourism industry that is planning on growing here in the next few years, because there will be a lot of people flying that will not have had the extensive medical evaluation that our astronauts do. And so this might be something that the commercial entities could use to help monitor and preserve the safety of some of their passengers.
Mayo Clinic in Florida has emerged in the last 30 years here and is in fairly close proximity to Cape Canaveral. Therefore, we're very uniquely poised to work with other scientists and physicists in the Space Coast community. What we're excited about is, due to technology rapidly advancing, due to Moore's Law, technology getting smaller, cheaper, faster, is never before has there been a time where patients can have something very either non-invasive or minimal monitoring their health at home using technology that was designed in space.
And I believe this technology can also be deployed into use in telehealth. So for instance, if you're having a consultation with a doctor via a video camera interface, that camera could potentially provide that doctor with your vital signs while he's examining you via video conference. So it can work in remote situations or situations where there isn't a lot of resources on the other end.
I think the launch that we have coming up later this year is a feasibility flight. So the first step in any trial, like for the NIH, a phase 1, 2, or 3 trial, phase 1 is usually feasibility, safety, or tolerability. We want to show that the technology works. The next step is to prove that on a larger scale, perhaps a longer duration flight of microgravity. But the clinical implications are for longer flights through space, to the moon, to Mars. And if you can show that this technology works in the extreme G-forces going to space, it has a lot easier application here on Earth, and for example, the patient's home, and allows them a lot more freedom rather than driving back and forth to the physical doctor visit. I believe that space medicine physiology is fundamental, primarily because there are things that you cannot test hypothetically in our laboratory unless you are in a microgravity or a zero-G environment. For example, Dr. Abba Zubair's experiment with stem cells to see if they would grow faster in space. You can't test that in Earth. You have to do the experiment in space. The applications really derive from human expansion into space or microgravity as a human population, and there are those companies looking to send humans up. We medically want to know the safety and how to medically monitor them so that we can do what's best for the patient's care.
Also, space is the ultimate resource-limited location, the farthest away from being able to reach help, the farthest away of being able to reach any kind of medical attention if they need to. So that if we develop this for the astronauts, then it could definitely be deployed on Earth and other resource-limited situations. It would be much easier to spread to those areas.
If you can track non-invasively through a camera someone's heart rate and respiratory rate on the moon, on the International Space Station, or in flight, there's tremendous applications easily to model that in the patient's home. This could be the elderly, this could be demented patients, eyes on a patient using machines and computers to screen for conditions. If they are having infection or sepsis, you can create computerized alarms to notify their family member and get them to the hospital sooner. And we know, regardless of what medical condition is, the sooner you get to the hospital or in more complex medical hands, the better we can improve outcomes.
Imagine a situation where an elderly patient is discharged from the hospital after suffering heart failure. Rather than spending many days in the hospital being monitored till they're more stabilized, they could potentially go home sooner because they will have a monitor at home that could record how they're doing and notify somebody if their vital signs change. If you go to NASA's website, they have a whole area dedicated to the spin-offs, the things that were developed in order to help people travel to the moon and into space and things like that. And then they have spun off into what we use and take for granted in our daily life.
There's data that every dollar spent on trying to push the boundaries of science that are in space come back and benefit humankind. I think the parallels, again, between healthcare and space is that the excitement comes from science. Science is very hypothesis-driven. Either something's going to work or it's not. And in healthcare, it's life or death. And so obviously we want hypotheses to work. We want to advance healthcare. We want to find cures for diseases. We want to make people healthier and live great lives.